15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on the Space Nuts podcast, episode 154. My name is Andrew Dunkley, and with me, as always, Professor Fred Watson. Hi, Fred.
Hi, Andrew. I know you're not feeling very well, so I won't say how are you. I'll just say I hope you're feeling better.
Yeah, got a dose of whatever's going around at the moment. It's the beginning. It's the beginning of winter, so not that you'd notice with the mid-20s temperatures we're getting here at the moment, but yeah, it's going around, and somebody threw it at me, and my body never rejects an offer. So thanks for that. I don't know where I got it from, but anyway, hopefully that'll just see me through the season after this. Now, we've got a lot to talk about. We're going to talk about yet another discovery that's been announced involving that flyby on New Year's Day of Ultima Thule. They've found that it's a bit of an odd bod. We've talked about how strange it is before because of the two flat surfaces that have sort of melded together. But there's more to it than that. The world's richest man has unveiled his vision for humanity in space and on Earth. He's got some wild ideas, but he's rich enough to pull them off, I reckon. And a couple of questions about chickens, eggs, and cosmic background radiation. That sounds like a microwave dinner to me. So we'll get into those a little later. But first, Fred, what's going on with Ultima Thule, or Thule, depending on which side of the equator you're on?
Well, while you're microwaving, you might put a couple of pancakes in, because that's what Ultima Thule looks like.
Indeed, yes. We did talk about that once before, but they've found something else that's interesting about it.
That's right. So
the fact that it's an absolutely boring rock. No,
yes,
I'm kidding.
Completely boring, which is quite a discovery, really. And the reason why we're talking about this is that the project, the New Horizons project, which of course flew by Ultima Thule at the beginning of the year, has the scientists involved in the study have basically just published their first kind of learned study of the results that they've got back from Ultima Thule. So that's why it's in the news again. So basically what they're trying to do is take the data that have come back so far, and it's more than we knew about at the beginning of the year. They've got much more detailed imagery and thermometry and all of that sort of stuff. They've taken all that and they've done a kind of analysis of what it's like, which they've reported in the learned press, what we call the literature. The lead scientist is John Spencer, who's one of the colleagues of Alan Stern, who's the project leader for New Horizons. Alan, I don't think he's there anymore, but he used to be at the Southwest Research Institute in Boulder, Colorado, which is really the center for this kind of study. So the outcome is exactly as you've said. Ultima Thule is totally boring, but that in itself is really interesting, if I could put those two contradictory ideas together, because what makes it boring is its surface, which is very, very bland. It's not, as everybody would have expected, peppered with craters, even though this object, and really it's two objects joined together. It's like the gingerbread man model that you invented back in January, yes, Andrew. So it's two things.
That me?
It was you, yes. A head and a body joined together like a gingerbread man. So two separate entities that have come together, but they're almost featureless. They show no sign of cratering, at least not obvious cratering. And even though these objects are thought to be pretty well the age of the solar system and probably largely unchanged since the solar system was born 4.6 billion years ago, what you expect with an old object like that, as you and I talk about many times, you expect an old surface to be riddled with craters. Like the moon's, the southern part of the moon, the southern hemisphere of the moon is just peppered with craters. And that's telling you that that's a surface that has not had much change since the early history of the solar system, around about 4 billion years ago. when the inner solar system at least suffered something called the Late Heavy Bombardment, when there was lots of debris flying around and many, many craters occurred. Ultima Thule shows no sign of that kind of activity, even though we believe that it is actually a relatively, well, a particularly ancient object. Not just relatively; it's one of the bits of raw material from which the solar system formed. And so the first question is, well, why is its surface like that? Why does it not have all these craters? And the answer seems to be that where it is, in the sort of outer part of the Kuiper Belt. The Kuiper Belt's one of a number of different groups of icy asteroids way beyond the orbit of Neptune. You can identify several different groups of those, which are principally determined by the kind of orbits that these objects have. Ultima Thule is definitely a Kuiper Belt object. In fact, I think it's part of what's known as the cold classical Kuiper Belt. It's cold in a dynamic sense, I guess, because that means its orbits aren't totally chaotic. The orbits are relatively circular and pretty well spaced out. And classical is because it was exactly what Gerard Kuiper and his colleague, I've forgotten his name. I was going to say Middlehurst, but it wasn't. Kuiper and anyway, the other guy who back in the 1950s postulated the idea of there being a belt of icy asteroids way out beyond the orbit of Neptune. I'm really annoyed I can't remember his name because I've got a trick for remembering that name, but I've forgotten the trick.
That takes me back to school with all the silly rhymes I used to try and remember so that I could answer questions because I couldn't remember anything.
I think it was Edgeworth. I think that was his name. I think his name was Edgeworth. Anyway, it's something like that. So the Kuiper Belt is... that's where Ultima Thule is. And the point that I was trying to get to before I went off on a totally random stroll through memory lane there, or lack of memory lane, is the point I want to make is that out there are very few objects. It's a very rarefied part of the solar system. The further out you get, the less stuff there is.
And it was Edgeworth. I just checked.
Oh, thank you. Ta-da. So my ruse for remembering it worked in the end. So the Kuiper Belt is, has not had that many collisions, and the kind of pristine surface of Ultima Thule is living proof of that, because for an old surface like that, you'd expect it to be completely beaten up, as exactly as Professor Spencer said, the lead author of this paper. But what is also interesting is that it's got sort of lumps in it. Remember Ultima Thule, it's about 300 kilometers, if I remember rightly, across. It's a tiny object, when you consider that it was discovered from Earth, or at least from Earth orbit, by the Hubble Space Telescope. But it looks as though it's been put together from smaller lumps. And as the authors say, you get the idea, this is Spencer again, you get the idea that it's built of different pieces. There's sort of subunits of about 5 kilometers across. And they've counted 8 of them on that bigger half of the two lobes, the larger lobe. So one of Spencer's colleagues is quoted as saying, it looks like monkey bread. And I don't know what monkey bread is.
I don't either. I'd never heard that term before, but I think it's like a conglomeration of lumps that are put together to create a loaf.
Exactly. It says it's a pastry-like snack in which balls of dough are baked together in a single pan, fusing into a lumpy loaf, which actually sounds pretty good to me. I like that kind of thing.
Yeah.
So, this fitting together of these different lumps is a really interesting aspect of it. And
could that be sort of like a very early formation scenario, like the way other bodies are created, like planets and things like that?
Exactly, that's right. That's exactly what they're speculating. What Professor Spencer has speculated about is that maybe these lumps of material were relatively soft to start with, and as he says, sort of smushed into each other as they came together. I'm not sure what the definition of smushed is, but it does kind of sound like the right word.
Yeah.
So that's, perhaps the most interesting aspect of this object, that it looks as though you can see the lumps from which it was made. And that's always of interest in very remote and ancient solar system objects like that. And just to tie up the loose end, the other thing is there's no sign of any kind of gases venting out from its surface. There's no sign of an atmosphere. And so far, there are no signs of any moons for Ultima Thule. Although they're still analysing the data, apparently they're still kind of looking for any sign of moons because the high-resolution data are still coming in. So it's interesting but boring.
Yeah, it is though, because it's two objects that are fused together now that seem to be made up of other objects that are fused together long before. They're flat, they're craterless, they're moonless, and they have very good traffic control out there.
Very much so. That's right.
Because they're not bumping into each other.
Indeed, that's exactly right. We expect more results to come out a bit later in the year, maybe around August or September. So it's as usual, it's a case of watch this space. But I think, for all it's boring, I think that's really interesting.
Very, very interesting. And we'll hear more about Ultima Thule in the not too distant future as they crunch the numbers, because I can't remember what the figure was, but the amount of data that came down was extraordinary. And
that's right.
They had to sort of fit it into an old, dial-up modem to get it to...
More or less, that's right.
Yeah, amazing. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Now, Fred, to the world's richest man, and he has just unveiled his vision for humanity, and he's talking about venturing out into space for some very good reasons, to try and basically make Earth just a garden paradise for everybody and everything that lives on it. Take all the industry away, that kind of thing. He's got some bold visions, and he's got the bank account to back it up.
Indeed, he has. So, this was a presentation by Jeff Bezos in Washington, D.C. And it's unusual because I think he's not particularly forthcoming when it comes to this kind of thing, unlike, of course, Elon Musk, who gets in front of a crowd at any opportunity. I think Jeff is a little bit more, slightly more reserved in putting out all his ideas, but he's apparently spoke for an hour at this event with a really good outline of what he has in mind. First of all, for his rocket company, which is Blue Origin, but more especially his really, big picture vision for the longer term future of humankind in space. And that's the bit that really interests me, because for what mine is worth, and it's not worth much, but the ideas that I've sort of tried to think about as to where we might be in 100 or a couple of 100 years' time are very similar to what Jeff Bezos is suggesting, but quite different from what Elon Musk is suggesting. So, it's nice to find the kind of things that I've been thinking about, clearly not so off the wall as I thought they were, because I thought I was losing my mind at one stage. Anyway, so the first aspect is to unveil his moon lander, which strangely is called Blue Moon. Everything in Jeff's company is blue. The Blue Origin is the company, and you probably know that his company is engaged in developing space tourism in a similar way to Richard Branson, except that rather than using a kind of aviation-type mothership to launch a rocket plane, Jeff's a straightforward up and down flights to the edge of space. And he's had many tests which have done very well. He's also, like Elon Musk, perfected the technique of landing booster rockets on their backside vertically and reusing them, which is a fantastic step forward. Both those entrepreneurs have got to be warmly congratulated for achieving that, because it really will make a difference in the cost of spaceflight. So Jeff unveiled his vision for going to the moon, and maybe for setting up a moon base there, which of course ties in with very much with NASA's vision, and no doubt Jeff's company will be one of the contributors to that, probably one of the contractors. I think he's already got actually one of NASA's lunar contracts for that kind of work, the multi-stage lunar lander. However, what really captured my imagination about this presentation is kind of what you alluded to at the beginning, the idea that, you know, our planet is the perfect world for us because we evolved on it, but it does have aspects of it which are uncomfortable. We have not looked after it. We've made it an industrialized world in many areas. It's a lot better now, I can tell you, than it was when I grew up, when the Industrial Revolution was still going on. I grew up surrounded by factory chimneys and smoke. I thought all stonework was black. I didn't realize stone actually had different colors. So he's focused on that and said, wouldn't it be great to get rid of all that and just make the Earth, the kind of place where we can all enjoy the kind of environment that we're really supposed to have. And the way he's suggesting we do that is to ship off a lot of the industry into space. And that ties in with things like asteroid mining, the idea of mining minerals and metals, and also rocket fuel in the form of water, which you dissociate into hydrogen and oxygen from asteroids, and not bringing it back to Earth. You actually do all your 3D printing and all your fabrication up in space. And he envisages something that these are things called O'Neill cylinders. And the idea came from a novel, in fact, written by a professor of physics, I think, at Princeton University, Gerard O'Neill, who suggested having these free, basically orbiting or certainly free floating in space, cylindrical space colonies. Where you build the thing and then you live on it. It's a little bit like what I was thinking of, and I gave a presentation on this in back there when I was in Kuala Lumpur a couple of weeks ago. I was thinking of what are called ring worlds, which are a bit like, do you remember that video game called Halo?
Oh, yeah, I love that.
Everybody lived on the inside of a ring. Well, you can do that. The physics works pretty well. It's just the engineering that's the drawback. And likewise with these O'Neill cylinders, which are, similarly huge structures because it's the rotation that provides the gravity. And if you want, then what you can do is you build your factories there as well. And
they actually portrayed that in the science fiction movie Interstellar, where humans had to leave Earth because it was dying because of global warming, same problems we're talking about.
Yeah.
And they had to solve the problem of gravity to get off the planet, which they did. And they lived on these ring worlds.
Yeah, I did see Interstellar, but it's quite a while ago, and things like that tend not to stick in my mind for very long these days. But I did like Jeff Bezos's thinking, and he actually there's a quote from him that really kind of went straight to the heart of my imagination, because he said, so his vision is up to 1 million humans living in each cylinder, built from asteroid materials and other resources, and the climate control and all the rest of it, cities, farms, mountains and beaches. What he said was, this is Maui on its best day all year long. And Maui's one of my favourite places in the whole world.
Haven't been to Maui. I've been to the Big Island and to Oahu, but lovely place. I also, I think you mentioned it, but he's unveiled a brand new engine.
Yes, that's right. Yes, thank you for reminding me.
10,000 pounds of thrust. The
4.5 tons.
BE7 is, I think it's called.
The BE7, that's right, and that's going to be the one that propels the. It actually propels the lander. Yes, the BE7, which will be, what the lunar lander is fitted with. I mean, 4.5 tons of thrust, and it's not a big engine. It's really remarkable, the engineering that's going into these things now.
Yeah, it is. It is amazing. And in time, the technology will get better and better, and we will be able to do a lot more out of the Earth's atmosphere, and manoeuvrability will improve, time to travel to places will improve.
Yep.
And his vision is sort of spanning generations. I mean, he knows
that's right.
that a lot of what he's aiming to achieve, he won't be around to see. He's talking 100 years or more.
Yeah, that's right. Absolutely. It's clearly, if you're going to build structures like that, we had the vision in, as you and I have spoken of many times, in 2001: A Space Odyssey, of these ring-like space stations, and maybe for something relatively small like this 2001: A Space Odyssey version was, you could do that in 20 or 30 years. But the kind of things that Jeff is talking about, and certainly the things I was referring to in my talk in Kuala Lumpur, are very much the long-term vision, hundreds of years. But I tell you, I still think it's better than trying to colonize Mars.
Yes, we've discussed that before, and it's probably a bit of a pipe dream. But I recently read a book by Kim Stanley Robinson, and the title is A Year 2413 or 2432. I can't remember. But in that, he designed a similar concept in terms of rather than creating ring worlds, they were hollowing out asteroids and living in them and creating terrariums. To live in. So similar concept. So, yeah, once again, sci-fi writers coming to the fore.
Yes, as they always do, just like you.
Well, I don't think any of my concepts will ever make it into space. They'll probably just crash and burn. Who knows?
No, I do like that Dr. Fred Wilson you've got in your book.
He's a classy dude. Yeah. Okay, we will probably hear more from the richest man in the world in the not-too-distant future as he unveils more and more of his concepts. Jeff Bezos, amazing man. This is Space Nuts with Andrew Dunkley and Fred Watson, of course.
Okay, we checked all 4 systems and keying was a go.
Space Nuts.
Now, Fred, a bit of a shout-out to the people who've added their following of us to Patreon. The Patreon account is growing. We've got a few more people who have put their money where their ears are, which I think is wonderful. So thank you so much for your support. And if you want to go to our Patreon account, it's patreon.com/spacenuts. I can't even remember. But, look it up if you're interested in contributing to the program. We are also on YouTube, so you can listen to the latest edition of Space Nuts on YouTube, or you can listen to back episodes via our YouTube channel. And we are now on Instagram, or our parent company is Bytes.com, which is the organisation that looks after our podcast and a bunch of others, is on Instagram. So if you're an Instagram user, look up Bytes, Bitesz, and add that one to your following list. It's following on Instagram, isn't it? Or Insta, as the kids call it. So, Bytes.com is the name of our parent organisation, and Hugh does a fabulous job piecing all the audio together and distributing it and getting it out, and he does a masterful job. He's really good. Now, Fred, we have some questions. This one comes from, now, who are we going to talk about first? Which one were we going with? The chicken and the egg theory. No, this comes from Marn. Now, I'm not sure if it's Marn, England, or Marn from England, so we're just going to call him or her Marn. Now, this is a chicken and the egg question. If most galaxies have at their centres a supermassive black hole, what came first, the galaxy or the black hole? Great question. Great question.
It is a great question, and it's great because we don't know the answer to it. I guess the thinking maybe 5 years ago or so was that, yes, you had to decide. One of them came first. Did you have a galaxy and then it evolved a black hole at the middle, or a supermassive black hole at the middle? Or did you have the black hole and the galaxy formed around it? And I think the current thinking is an amalgam of both, that basically they form together. That you start off with basically a cloud of hydrogen, which is what galaxies start from, and star formation takes place within that cloud. Its rotation flattens it down to make like a spiral spiral galaxy. But at the same time, you're forming black holes in quite large numbers, because the very earliest stars to form are the most massive ones. They're very, very massive. Probably the first stars were more than 100 times the mass of the sun. And they've got very short lives. They burn out very quickly. They're incredibly bright. They burn their hydrogen fuel quickly. They might not last more than 10 million years or so, which is a blink of an eye in cosmic time. And then they turn into a supernova. And because they're so massive, the remnant of that supernova is not, or the remnant of the core of the star is not a neutron star. It just collapses straight down to a black hole. So you will wind up with the center of this cloud of star forming with a lot of black holes there. They are interacting gravitationally, and it seems very likely that early in the history of the universe, they will be coalescing like mad, merging in the same way that we've now been able to detect black holes merging with the gravitational wave detector. But in the early universe, that was a frantic process with these mergers taking place, particularly in the cores of the baby galaxies. And so what's likely is that the two processes of the formation of a galaxy and the formation of the supermassive black hole basically went on concurrently. And over time, because most galaxies are, 10 billion years old or more, what we're now seeing, particularly in the nearby universe, which is where all the elderly galaxies are, we're seeing pretty well all galaxies having a supermassive black hole at the middle. And it looks as though the black hole has grown with the galaxy. That's the bottom line.
So we're saying they formed together?
Yes, that's the answer.
So
as far as we know.
There wasn't a first, there was it all happened at once.
Yes, I think that's right. Yeah.
Okay. So it's not a chicken and an egg. It's just
it's an embryo.
Yes, that's what it is. Yes. All right.
The joke's on you.
Oh dear, oh dear.
All right.
Thank you, Man, for your question. Hopefully that answers it. One nor the other were first. It seems that we think at this point it all happened at once. Now we move on to our next question. This one comes from Andrew Mitchell, and he says, I hope you're doing well on this election day. He must have written this last Saturday because we had a federal election. Did you get your democracy sausage? For those who aren't aware, one of the traditions in Australia on election day is to have a barbecue or a sausage sizzle. And no, the answer is no, I did not get a democracy sausage. They didn't have a barbecue at the polling booth that I went to. But it was an interesting weekend. I don't think things unfolded anywhere near what most people expected. It was fascinating. I spent all Saturday night watching it. I'm a bit of a geek like that. Anyway, Andrew's question is, my boy is doing Year 11 physics, and we've had some interesting chats about the universe. He just asked me if we can detect the cosmic microwave background getting redshifted. That is, between our earliest observations and now, have we noticed if the cosmic microwave background microwaves arriving are slightly longer wavelengths? I suspect that the change over a human lifetime would be small so that we could not detect them, but I'm interested in Professor Fred's answer. So he's got a bit of an idea of where he's headed with this one anyway. Is he on the right track?
Yes, he's got the answer. But just to explain what the question's about. Okay, so our universe started with a big flash called the Big Bang. If you look back far enough in time by looking far enough out into space, you can still see it glowing. And that's what we mean by the cosmic microwave background radiation. It's a radiation which is now at microwave wavelengths all over the sky. It's everywhere. And what it means, it corresponds to you're looking back to a time when the universe was not transparent. It was still glowing brightly from the Big Bang. In fact, it was glowing brightly 380,000 years after the Big Bang. It was still very much a luminous object. So what we do with the microwave telescopes that can sense this, you look basically out with the most high sensitive equipment you've got, and you see that all over the sky there is this radiation background, which started its journey 13.8 billion years ago as visible light. So to get from being visible light to microwaves, it's been stretched by the expansion of the universe. And in fact, that gives you the clue to the answer to the question, because the universe, that radiation that we're seeing left its source 13.8 billion years ago. It's been stretched by a factor roughly of 1,000. It's a little bit more than that, but for the sake of argument, we can say it's been stretched by 1,000 from visible light to microwave radiation. So if on average, if by now it's been stretched 1,000 times, you can say that on average, over the last 13.8 billion years, it's been stretched by 13.8 million times per year. It's been stretched by 13.8 million per year. That's what I'm trying to say.
Okay, yeah, I see.
So every year its stretch is very, very small. And, it's now rather more than 50 years since we detected the cosmic microwave background radiation. So you're still talking about one part in, maybe one part in a million or something, one part in 500,000 of stretching that you're trying to detect. And because that radiation is what's called a blackbody spectrum, it's a rather smooth spectrum. If you look at the way the light intensity changes from violet to red or through the microwave spectrum, it's quite smooth, and a change of the order of a few hundred thousandths, one in a few hundred thousand, is not possible to detect. So the answer is no, we can't detect it, but it is a really, really good question. And hats off to your year 11 son for actually
tackling physics at high school. I think that's remarkable.
Well, but the question itself is, it's a very, very interesting one.
Yes, indeed. Well asked and well answered, I might say, Fred. And you put those two questions together and you get a TV dinner.
Which itself has been microwaved.
Indeed. It's the only way. Well, that's just about it. Thanks to everyone who put their questions in. We're working our way through them, and we do appreciate your feedback and your questions and your support. And it's always wonderful to be able to help you out with your questions. It's become a sort of a normal part of our weekly presentation now. And because if we're not telling you what you want to know, then we're barking up the wrong tree. And Fred, as always, it's great fun. Thank you so much.
It's a pleasure, Andrew. It's always good to talk, and I look forward to speaking next week.
Indeed. Fred Watson. And we'll be back next week. And thank you again to everybody who's following us on YouTube and Instagram through bitez.com, B-I-T-E-S-Z, and to the 11 people now who are patrons of Space Nuts. And that website is patreon.com/Space Nuts. So I did get something right today. Thank you again for listening, and we'll be back again next week with another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast. Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from bitez.com.